Hello all, welcome back. In this session, we are going to see Naive-Bayes classifier in machine learning algorithm that comes under supervised learning. And the subtopics we are going to see under in this session is a tutorial problem related to Naive-Bayes and what's the concept that is called using Laplace smoothing, and one tutorial problem for you people to do on your own. And what is meant by Bayes theorem? Bayes theorem describes the probability of an event which is based on the previous event. The Bayes theorem is the extended version of conditional probability. And in next slide, let me have a short intro about conditional probability and then we can get into Bayes theorem. Bayes theorem provides a way to calculate the posterior probability, the probability of A given B from probability of A, probability of B and probability of B given A. How this comes? It comes is an extended version of conditional probability. The probability of y given x, which is equal to the probability of x given y into probability of y divided by probability of x. In other term, we can call this as a posterior term, and this probability of x given y, call it as likelihood, and probability of y we can call it as prior, and probability of x we can call it as evidence. I can relate this equation with the help of a doctor-patient conversation. A patient is going to meet a doctor. The patient is affected with cold and fever, and based on the input data given by the patient, doctor going to assume it may be a typhoid or dengue. That is a prior assumption without taking blood sample. That is called prior. Doctor assume on its own based on the data given by patient. And what is the posterior probability of y given x? And doctor has some doubt. He or she asked to take some blood report, take some blood sample, and blood sample, with the help of blood sample report, the doctor able to predict y given x is nothing but blood sample report. That is called posterior. And while you meet the doctor itself, he or she may ask you whether any other in your house is affected with fever and cold. That is called likelihood, probability of x given y. Same way you can interrelate with some other example and you can have it in your memory. Yeah, now Bayes theorem. So this Bayes theorem, you can consider an example for Bayes theorem. You have an 52 cards in your pack, and the probability of A is probability of card is red. That is called event A, and that event A I am called as probability of A. So the how many red cards will be in your pack of 52 cards? It's 26, and remaining 26 will be a black card. So 26 divided by 52, that is a probability of A, and probability of B is probability that the card is king, right? The event B. Out of that 52, how many kings will be there? 4. So 4 by 52. So probability of B given A, that is called conditional probability. The probability that the card is king given that it is red. How many kings are present in red? Roughly only 2 cards will be there. So there is 2 divided by 26. So what is posterior probability? Probability of A given B. The probability that the card is red given it is king, that is B. So it is given in the equation term probability of B given A into probability of A divided by probability of B. So if you simplify this term, you will get 2 by 4, which is equal to 1 by 2. It clearly defines the Bayes theorem. So Naive-Bayes. So Naive-Bayes classifier, this classifier indicates it is used for classification purpose, and Bayes says that it works based on Bayes theorem. And what is meant by naive? Naive has a simplistic assumption that features in the data sets, features by mean input features or input variables in the dataset are independent from each other. They are not dependent, they are independent to each other. It estimates the conditional probability which is the probability that event A will happen given that event B has already occurred in past. So hence used to classify target column based on the given feature, and it is easy to implement, fast, accurate, and can be used to make real-time prediction. And the tutorial problem for this case, I am going to consider it as 14 data points. I am going to consider, and the input features are outlook, temperature, humidity, wind, and output feature is play tennis or not. And we can get into the condition. What you need to find? You need to predict the output for x dash given outlook is equal to sunny, temperature equal to cool, humidity equal to high, and wind equal to strong. Given that probability of S is given as given sunny, cool, high, strong, and probability of no given sunny, cool, high, and strong. We can calculate all those values one by one. And first and foremost, we can calculate the probability of yes and probability of no in the given data set. Out of these 14 data points, probability of play tennis, the people who say yes is only 9. So it is 9 divided by 14, that gives you 0.64. And probability of no is 5 out of 14 data points, so it is 0.36. So probability of individual class, we got the answer. Now we are going to look at the outlook. In outlook, we have 3 subcategories, namely sunny, overcast, rain. In sunny, how many members say yes? When condition is sunny, how many members say how many days you can play tennis? In sunny, if you look into this data points, D9 and D11 say yes. So it is 2 divided by 9. And remaining 3 sunnies, for example D1, D2 and D8 say no. So it is 3 divided by 5. Same way, now we can look into overcast. In overcast, see, there are only 4 overcast, D3, D7 and D12 and D13. All the 4 overcast say you can play tennis. So it is 4 divided by 9 and 0 divided by 9. Now rain. This rain says how many out of 5 rain conditions comes under outlook. Out of 5, 3 says yes. 3 days you could able to see yes, or D4, D5 and D10. So it is 3 divided by 9, and for no it is D6 and D14. It comes under no, that is 2 divided by 5 is the probability ratio. Same way, first feature gets over. Now we are getting into second feature, temperature. In temperature we have 3 conditions, namely hot, mild and cool. Same way we can calculate how in hot condition how many days you can able to play tennis. Out of hot you have only 4 conditions, D1, D2, D3 and D13. Out of these 4 cases, D3 and D13 comes under yes. So it is 2 divided by 9 and it is 2 divided by 5. Right? Same way, mild, under mild you could able to see there are 6 miles are there, and the 6 miles you could able to see 4 miles say yes, that is D4, D10, D11 and D12 says yes. So it is 4 divided by 9 and no is 2 divided by 5. Same way you can calculate for cool. For probability of S is 3 by 9 and no is 1 by 5. The second feature gets over. Now we are getting into the third feature, humidity. And the humidity you have only 2 subclasses, one is high, another one is normal. Under high, totally you have 7 data points. Out of that high, 3 says yes, namely D3, D4 and D12. And no, it is 4 divided by 5. Remaining things are no. Under normal subclasses, you have 6 says yes, namely D5, D7, D9, D10, D11 and D13. And remaining one says no, that is D6. Now we are getting into the fourth subfeature, windy. Under windy you have 2 subclasses, namely strong and weak. In strong, you could able to see total strong is 6. Out of that 6, 3 says yes. And what are they? The days are D7, D11 and D12 says yes. And no is 3 divided by 5. And week, if you see week, out of 8 weeks are there, out of 8, 6 weeks says yes. Namely, D3, D4, D5 and D9, D10 and D13. Totally 6 comes over here. So it is 6 by 9 into, and the probability of no under weak condition is 2 by 5. With this data as an input, we are going to calculate the predicted output for the condition outlook is sunny, temperature is cool, humidity is high and wind is strong. Now we can say for features probability of yes when it is sunny, outlook is sunny and temperature is cool, see here, and humidity is high and wind is strong. What is the probability? The overall label is probability of yes. If you substitute all those values here, probability of sunny, what is here, 2 by 9, and probable temperature when it is cool it is 3 by 9, and humidity when it is high it is 3 by 9, and for windy it is strong it is 3 by 9, and overall label for say a play tennis is 0.64, that is 9 by 14. If you simplify, if you multiply all those values, you will get 0.0053. Same way, calculate for play when not to play tennis. No, that is no. If you do all those steps, you will get 0 probability of play not to play tennis is 0.0206. If you see which value is higher in this two thing, so 0.02 is higher compared to 0.005. So the answer is the predicted output for the particular condition is not to play tennis when outlook is sunny, temperature is cool, humidity is high and wind is strong. Same way. Now let me change the outlook as, instead of sunny, let me take outlook as overcast. Let me take outlook as overcast. See here, the outlook of overcast is not to play tennis is 0 by 5. In this condition, right, in this condition the play tennis is 0.0053, but not to play tennis is, if you multiply, one term becomes 0, so the whole term becomes 0. So automatically for this condition the 0 is less than 0.0053, so automatically you need to say you can play tennis. But this is the wrong approach. If any one value, the probability term becomes 0, so this is, the condition is false. You should not consider like this. For that case only you are going to introduce a term called Laplace smoothing. In that case, if any one term, probability of particular term becomes 0, we need to add and 1 to numerator and denominator for that empty category. And if you do that case, in this case you need to skip it. This term you need to skip. For when outlook is overcast, you need to skip this and calculate for the remaining terms. It will become 1 by 1, right? Then the answer will be 0.0342. Just now compare. For outlook equal to overcast, temperature equal to cool, humidity is high, wind is strong and overall label is, considering overall label. Now not to play tennis is 0.0342 is higher compared to 0.0105. So you can say the predicted output for the condition given is not to play tennis, right? Okay, here is the task for you people. Consider this data set. In this data set you are going to say for this particular condition the given mail is spam or ham work, and type your answer in comment box below. Thank you all. We'll meet you all again in another video. Thank you.